So I'll start with a question. How big is a token for training ChatGPT or LLM? How many bytes is it, roughly? Anyone? A couple of bytes, right? And how big is an image? Typically, is about 10 megabytes. So you can fit a training set for ChatGPT on a micro SD card, but our customers, we mainly work with imaging, they need 35 hectares to fit their data. So this is a real picture with real data from our customers. The scale of it is similar to the EPFL campus. And also what you can see here, these parking spots are not for cars, they're for trucks. Because the way that data is being shifted nowadays is not by car, not by the internet, but is with hard drives on the back of trucks. And of course, this is not really scalable, right? So if you want to scale AI to beyond 100, for example, autonomous vehicles or 100 diagnoses, you really need to deal with a lot of data. And the growth is about 50% per year right now. This is very, very expensive. Also, if you consider that you have to label this data, you have to train and you have to shift it backwards and forwards across your different systems. And the other aspect is that you have a lack of standards. You don't have interoperability, meaning I change the camera on my car, I change the microscope that gets my data, I have to retrain everything. I can't say that, well, my AI model is going to work with 99% efficiency on that data. And of course, with a car, you hope that you have much higher than 99% efficiency and accuracy. So basically, if you want to scale from 100 vehicles that Waymo have, for example, right now, that effectively drive on tracks, you have to really increase the reliability and really reduce the cost and really increase the performance by a massive amount. Our assumption is that you can do this with a platform that is physics-based, that puts physics-based concepts into AI. The platform is called JetRo. The technology behind it, sorry, I'm going to go a bit technical here, is that when you take an image with an instrument, that image contains lots of data, and each pixel, now you don't know how much noise you have in it. It's a mixture of noise, it's a mixture of signal, and it's a mixture of redundancy. However, if you now take a physical model of how was that image taken, how many photons hit that pixel, what you can understand is, well, that data, on those 16 bits, I have only 1 bit of information. And this is really important, both for storage and transferring data more efficiently, but also for understanding what is behind your image. So it gives you, a JetRo image basically is an image that has superpowers thanks to physical models that are embedded. It allows you to compress the data, to transfer it much faster, and to save lots of money. It allows you to synthesize through physical models like many different aspects of your data. For example, what if my camera is too hot? What if it was slightly out of focus? But not only that, it allows you to act during the training process. And this is something I actually learned from Marco, is that AI models typically establish correlations but can't distinguish causation. Like with a good example on, well, if you have high cholesterol, you're probably old, but it's not that cholesterol makes you live longer, right? And so, whereas if during the training process, you can act on your data, on your physical model, you can break that symmetry and you can distinguish causation for correlation. If the camera is too hot, it's going to be too noisy, my results are not going to be good enough. Simple example. And so that allows you to move from just training to more teaching to the AI. Like if you learn, if you have children, they might learn, I'm a pirate. Well, you don't start with the hardest version right away. You start with the easiest version, and you move towards a harder version over and over as you go along. So also, I wanted to give a hint of why we're called Dotphoton, because we're really physics-based. The photon is a natural standard for illumination, for everything that's imaging. And our product is called JetRaw because we work with raw photon counts. So what's the advantages of the platform? Well, the first one, and honestly right now is this one that has the most traction, is the savings that you have. As you can see, you can save about 80% of your budget on storage and transfer. The other advantage that everyone likes is performance. So here we compare our transfer manager, JFS, with the second best, S5CMD, on transferring a data set. So you'll just see the performance. They just start. JFS takes about 12 seconds. Done. Okay, a few more, maybe 20. And S5CMD hasn't started yet. And I'm not going to wait because it takes about 2 minutes to transfer the data. Now let's look. We looked at things that are useful for everyone, so save money, save time. But now let's look at different examples of what you can do with this platform. This is data from EPFL, Oates Lab. It's a zebrafish embryo. Now what you want is to measure you want to segment the cells, but you want to use the least possible laser power because these fish like the dark. So normally you would have to test lots of different laser powers and see which one do I need. But if you now have synthetic data, you can only take one picture, synthesize different images with different laser powers, and apply your model and see what is the best choice for that specific situation. Another example is you can achieve superhuman resolution. So here, and the person who did this model, Marco, is on our booth. You can come and visit us. We say, well, like how can we transfer a drone image with all, here we applied 6 different physical models to transfer that image where you can segment the cars very well, and you can actually see them on the parking lot, to how that image would look from a satellite. And now you have some accurate labels, and you can get really accurate data from the satellite image, where by eye you wouldn't have a chance of recognizing things. So you can get superhuman performance this way. The other aspect is that you can, as well, put the design parameters of your system, of your satellite, and we already, the first launch of our technology was in November last year, so it already works on satellite. You can put the design parameters even before you launch. So you know, oh well, that satellite will have that performance with my AI. So this technology has been available for already 2-3 years to our large customers, but what we're doing now is we're making this easily accessible because our target is not the large customers. We want smaller customers to be able to work themselves and have all these features in an easy way. And this can be done through our platform. Ariane is at the back. She's responsible for it, so come and talk to us. And you can deal with petabytes of data just as you would your files on your laptop with a simple file browser. And these also represent data sets which you can load through a data loader like PyTorch or other, which represent both the real data that you have, but also the synthetic data. So you have these 3 elements in our product, the JetRaw core, so this is hardware or software for manufacturers. It basically increases performance. Then you have the platform, which makes it nice and easy to deal with lots and lots of data. And then you have so then you have the Platform Pro version, which has the synthetic data abilities, and also we have a service to help you getting started with these physical principles in imaging. So we actually like the left hand, so the core and the pro have been available for a while. The platform is right now in beta, so come and see us if you're interested in early access to that. So customers are very disparate. I put a few here. However, we're very grateful. We had quite some growth. We have quite a bit of data that we are managing. This is good, of course, for us. It's good for the customers, and is also good for the environment. We saw that we already saved, thanks to the compression and efficiency gains that you have from our platform, more than 1,000 tons of CO2 last year. We are based in Zug. You can come and see us. It's an absolutely beautiful city. We're also very much involved in standardization bodies, so AI for Health, but also Croissant is a data loader that allows you to search different data sets. We work on standardization with Google and Meta on that. And Quadriplimi, which is standardization of image quality, especially for AI for microscopy and diagnostics. So thanks a lot for your attention.
Thank you very much, Bruno. So it's time for your questions. Last time before the lunch break. Any question?
Yeah, that's very interesting. So I'm just trying to understand. So the image in my view, it's like a multi-dimensional array of numbers. And you're talking about like images specifically, but if I consider it as this object of numbers, so it's not bounded only to images, right? So it's probably could scale. And what you're talking about, is it like a smart way of compressing this array of numbers?
Yes, it is. However, the smart way about it is that images, they come from a very specific process. So quantum physics is very much involved there. That's why with images, the signal and the noise is very intermingled, and you can't separate them easily. But what you can do is understand those two components very well. And so the technology is quite advanced, but with imaging also, several of us come from that field, from sensor manufacturing. We can build those physical models very, very well. And whereas in other fields, the same techniques would work, and indeed we want to open our platform eventually to other fields, but we also feel that, well, a big part of our brain is dedicated to image processing. Of course, LLMs are very important, but that's all human-generated data. Eventually, we expect that the biggest use of AI is with machines looking at the physical world themselves and learning on the physical world themselves. That's why we, as a strategic aspect, we focus on imaging.
Yeah, thanks.
Any other question? At the back.
Thank you. It was very interesting. If I understood correctly, your value is in basically compressing a lot the image in a way that you improve the transmission performance, and the cost for it is the decompression. So you will need to decompress the image later. How fast is the decompression?
On my laptop, I get about 3 gigabytes per second.
Okay. Yeah. Thank you.
And also that's only part. So the decompressor can also synthesize data. So you get when you get an image, you only transmit a compressed image, and with that image, you might generate, well, first you decompress it, and then you generate a whole bunch of images, which now are suitable for training because they're not AI generated, but they are generated through physical models that are, one, very, very fast, and secondly, they do put some kind of intelligence or information in, so you can use those for training properly. So effectively, at least for our customers, they pay a lot for GPUs, but those GPUs are often waiting on I/O. And so with these techniques, you can speed up your training very, very much.
Interesting. Thank you.